All right, guys. The next set of notes are on, we're entering this thing called bond hybridization, which is a theory that answers questions to help us explain how these Vesper geometries actually happen. Like, how do we actually get those shapes? And so before we actually jump into the real bond hybridization, I can't speak anymore apparently, we are going to do some practice on orbital diagrams. So these help you figure out what kind of bonds are happening if you can draw a really nice orbital diagram. So they're pretty simple. They have to do with the electron configuration. So you're always going to write out the electron configuration first. You're going to create the orbitals that go with each SPDF orbital. And then you are going to follow the Aufbau principle. Aufbau is a German house, and in a German house back in the day, the first, like your great-grandpa, so GG-pa, great-grandpa would build a house, right? And then your grandpa would come along and, well, he would have kids, right? And then his kids would be like, oh, I want to live in your house too. And they'd be like, great, well, we'll build a floor on the house for you. So now your great-grandpa's there, your grandpa now lives in this house. And then he has a family, raises his children, and those children are like, cool, we want to live in that house too. And so then they're like, well, that's fine. We can just add on a whole another layer. And then this is where your pa, I guess your dad, lives, and you too. So this is how houses were built in Germany a long time ago. I don't think they do this anymore. It sounds crazy. But this is the Aufbau principle. And the idea is that you're filling from the lowest energy level. So you're building bottom up. We're building from the lowest place up to the top place, right? The ground level electrons, or the ground is where you start building, and then you can go up from there. So same idea here. That's the background to that story, though, in case you were wondering. And then Hund's principle, this tells us that when we build our orbitals, we need to fill them one electron at a time with the same spin. Okay, one electron at a time with the same spin. And then the Pauli exclusion principle means we can't exclude anybody. Once everybody has one electron, we're going to give them a second electron, because we know electrons like to travel around in pairs. And that electron is going to be in the opposite spin. And this is true because electrons truly travel around in opposite spins. So it's cool. But here we go. We are going to look at these different orbitals, and if you remember, these are all of the orbitals. There's the s orbital. There are the p orbitals. They're in the shape of little dumbbells, and there are 3 of them, and they all kind of get stacked on top of each other into like one big blob of p orbitals. It kind of looks like a big balloon art, but we like to look at them separately because there are 3 orbitals. They each hold 2 electrons in them, right? Every orbital can hold 2 electrons. And then we have our d orbitals, which start to get more intense. They can all hold 2 orbitals. You kind of see the different shading. There's like the dark blue and the light blue. The dark blue is where 1 electron can travel around, and the light blue is where another electron will travel around in here, and that can hold 2 electrons each. And then the e orbital not the e orbital, the f orbital, I'm just looking at all these e's, can hold 2 electrons in all 7 of their different orbital shapes. So there's these crazy shapes, clouds, right, or orbitals where the electrons live, and then we place 2 electrons in all of them. So in the end, the s orbital can hold 2 electrons, the p orbital can hold 2, 4, 6 electrons, the d orbital holds 2, 4, 6, 8, 10 electrons, and then the the f orbital holds 2, 4, 6, 8, 10, 12, 14 electrons. And now this matches up with the periodic table because we know that the s orbital is right here, this chunk of the periodic table, right? And the s orbital can hold 1, 2 electrons, 1, 2 electrons, 1, 2 electrons. And that is true. The s orbital can hold 2 electrons. The p orbital can hold 6, and that is true because there are 3 little orbitals where each set of electrons lives. D orbital can hold 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's true because there are 5 suborbitals where 2 electrons live. And then again, that's true for the f orbital, 14 electrons, where there are 7 suborbitals for all of them to go. So this follows the periodic table quite nicely, and it is what the electron orbitals actually look like. It is what atoms actually look like. And I'm going to have a video, the next video is for you to actually look at these orbitals and what do they actually look like when we start building them on top of each other. So It'll make more sense when you actually see a video of it, because it's really hard to like picture this as three-dimensional. But these are all three-dimensional. So what we're really going to look at, though, is writing how we like represent these orbitals in a picture, because again, I'm not going to have you try to like draw all of these stacked on top of each other. That's impossible. So instead, we draw them with arrows in little boxes or on top of lines. So for example, we have oxygen here, and we are going to write the electron configuration, and it is, just in case, I mean, you have it right there, but just so that you remember how to get it, you start at the very beginning, you stop at 8 electrons. Remember that these are kind of like placeholders for all of the electrons, even though it's also the periodic table, it's also an electron placeholder. So in my first row and my first energy level, I hit the s orbital, and I can place 1, 2 electrons in the s orbital. So 1, s, 2. That's 2 electrons. Then we're going to go the second orbital, or the second energy level, still in the s orbital. So 2s, 1, 2, 2s2. And then we've got the second energy level again. We're in the p orbital, so 2p, 1, 2, 3, 4. So 2p4. Okay, that is exactly what this says. 1s2, 2s2, 2p4. Okay. I know we did this last chapter, but I'm just going to remind you all because it's still here. And so we're going to add the next piece of this, and this is to draw these orbital diagrams. We know that the s orbital, it only comes with one little s like cloud, and so that's representing my s orbital cloud. And inside of there are 2 electrons, and so I have an arrow going up and an arrow going down showing those 2 electrons in there. And it's true, the electrons are truly spinning in the opposite direction of one another because they don't want to be near each other, right? So they are actually repelling from one another by spinning in the opposite ways. And then we've got our 2s. So I've got my 2s orbital here, and again, it's an s orbital, so it's just one line because there's only one of them. And I'm going to place 2 electrons in it, one going up, one going down. And then we've got p. So 2p, and it's 1, 2, 3. So I'm representing these 3 orbitals without having to draw them, but instead putting little boxes. And in each box, I'm going to place my electrons. I'm going to place up to 4 of them. So I'm going to start by placing 1 up, 1 up, 1 up. Like, everybody wants to have their own room, right? I'm not going to share my room unless, well, true story. Me and my siblings, there were 2 rooms and 3 of us, right? And so me and Karen, we had our own room, living the best life ever. Also, unfortunately, her name was Karen, so not the best life. But we had our own rooms, and then Jennifer came along. And so when Jennifer came along, some of us had to start sharing. And of course, Karen and I had to start sharing. Even though I'm the oldest, I should have got my own room. So our house looked like this. Karen and I in a room, and Jennifer on her own. So that's what's happening here. Electrons are not going to share rooms unless they have to. So they all get their own room, and then, we have a 4th electron, so we've got to go put it in the first energy, or really any of the boxes is fine, but I always start at the beginning, and have it face the opposite direction. Okay, so I'm actually going to draw one of these out. There's 2 more examples here you can look at, but let's do one that's not on here. Let's try out nitrogen. No, let's do something a little bit more. How about sodium? Okay, so we're going to write the electron configuration, and I'm going to write it just spaciously down here so that I can have space to draw these orbitals as well. I'm going to try to do 2 at once. So sodium is here 11 electrons, and so I'm going to start with 1s2, and then 2s2, 2p6, 3s2, 3p6. Oh, no, I'm not. I lied. 1s2, 2s2, 2p6, 3s1. I'm just going to stop right here at 1. So I'm going to write that out. 1s2, 2s2, 2p6, 3s1. And so now, just knowing how many orbitals are present in each of these, I know that the s orbital has 1 little suborbital, s orbital has 1, s orbital has 1. The p orbital, on the other hand, there are 3 of them, right? 1, 2, 3. And so I'm going to place 1, 2, 3. And then I'm going to place my electrons. So this one gets 2, 1 going up, 1 going down. This one also gets 2, 1 going up, 1 going down. This one gets 6, 1 going up, 1 going down. Okay, if you want to be like a fancy chemist, you can just do half arrows, and then it's significantly faster for fun. Well, not for fun, that just makes your life easier. And then 3s, I only need 1 electron, and I'm going to start with it facing up. There we draw the whole thing if you want. Okay, so that is how we draw these. There is a link to like simulation. Actually, I'm just going to bring it up really fast. SPDF simulation. And I will place this in the slideshow as well, or you'll see it's already in there. If you run the simulation, it will show you all of these. So if you want to check your work, or you're like, oh, I don't know, maybe I'm right, maybe I'm wrong, maybe I actually want to see my orbitals being built, you can use this simulation. And how it works is you can click your element. So we just built sodium. Okay, so sodium, you can see that light cloud in there. That's the first s orbital. This is my second s orbital. And this is my third s orbital, right? They're all stacked on top of each other. So those are all my s orbitals. And here's even the diagram over here. So you have this to look at. And then we've got our p orbitals. And our p orbitals are all of these the balloon creature thing in the middle, right? And those are all 3 of them. So those match. That's how all of, I guess, these, where do I go back to my visual here? That's how all these look when they're stacked on top of one another. They look like that, right? And moving in the middle. So this is linked in there if you want to check some of your work while you're doing this. They do every, look at that, single electron configuration for every element, and they have the arrows. So if you need to see if you're doing it right, use this. And I am going to stop this video right there, and then I'll have the next one. Sorry, it only lets me do 15 minutes at a time, and we're at 11, so